What does it mean for a function to increase and decrease? Well, the function on the left is increasing because it's going up, and the function on the right is decreasing because it's going down. Now, how do we know if f is increasing or decreasing? Well, since it's going either up or down, we can determine this looking at the slope. If f is going up, then the slope of f is positive. And of course, another word for slope is the derivative. So we can say that f increases when the derivative of f, or f prime, is positive. Furthermore, f goes down, or it decreases, when the slope is negative. So f decreases when the derivative f prime is negative. Consider y equals x cubed minus 4x. Let's determine where this function increases and where it decreases. Now, to determine this, we need to find out where the derivative dy dx is positive and where it's negative. So, let's first take the derivative of y. dy dx is equal to 3x squared minus 4. And we'll set this equal to 0. The reason for this is because consider some function f of x that looks something like this. Where is f positive and where is f negative? Well, f is positive when the function is above the x-axis. And where is f negative? Well, when it's below the x-axis. Now consider what happens in between where it's above and where it's below. It hits 0. The only time a function can change sign is if it first goes through 0. We know this from the intermediate value theorem, of course assuming that f is continuous. So this is a continuous function right here, and the only way that it can go from positive to negative is if it first passes through 0. And of course from negative to positive if it first passes through 0. So what we can do is we can set our derivative equal to 0, since the whole point of this is to figure out where our derivative is positive and where our derivative is negative. So we'll set our derivative equal to 0, and then we'll plot those points and look in between them to see whether our derivative is positive and negative anywhere else. You'll see what's happening in just a second. So let's set this equal to 0 and solve. We'll add 4 to both sides, so 3x squared is equal to 4. That means that x squared is equal to 4/3, and we get to the square root of both sides, yielding x is equal to plus or minus. The square root of 4 is 2, over the square root of 3 is just root 3. So here are the 2 points where the derivative is equal to 0. What we're going to do now is we're going to create a graph, a line graph, for our derivative. Our derivative is y prime. We'll graph negative 2 over root 3 as well as positive 2 over root 3 on this graph. The reason is because we know that the derivative crosses the x-axis at those 2 points and no other 2 points. No other points, period. So what this means is everywhere in between negative 2 over root 3 and positive 2 over root 3, our function will either be above or below the x-axis. It goes for everywhere to the left of negative 2 over root 3 and everywhere to the right of 2 over root 3. So all we have to do is check a point in any of these intervals, and that will determine whether our derivative is positive or negative. And that was the whole point here, was to figure out where our derivative is positive and where it's negative. So let's pick a point to the left of negative 2 over root 3, like, for example, negative 5. If we plug negative 5 into our derivative, we get negative 5 squared is 25 times 3 is 75 minus 4. That's positive. So our derivative is positive to the left of negative 2 over root 3. Let's check in between negative 2 over root 3 and positive 2 over root 3. A pretty easy point to guess is 0. Let's check 0. Plug 0 into our derivative. 3 times 0 is 0, minus 4 is negative 4. That's negative in here. And of course, to the right of 2 over root 3, let's check positive 5. 5 squared is 25 times 3 is 75, minus 4 is still positive. So over here, our derivative is positive. Now let's go back for a second. Y is increasing when y prime is positive, and y is decreasing when y prime is negative. Well, where is y prime positive? Well, to the left of negative 2 over root 3 and to the right of 2 over root 3. And so we can say that y is increasing on the interval from negative infinity to negative 2 over root 3, not including negative 2 over root 3 because the derivative is 0 there. When the derivative is 0, our function is neither increasing nor decreasing. It's just remaining constant, essentially. And union from 2 over root 3 off to positive infinity. Furthermore, y is decreasing on the interval from negative 2 over root 3 to positive 2 over root 3 because y prime is negative in between those 2 points. And this is our analysis of where y is increasing and decreasing. Let's do another one. Y equals x cubed plus x squared minus 8x plus 5. Where is y increasing and where is y decreasing? Well, first, let's find dy dx. dy dx is equal to 3x squared plus 2x minus 8. And let's set this equal to 0. To solve this, we can factor. So we'll have 3x times some x will make 3x squared. To make negative 8, probably negative 4 and positive 2. That's positive 6 minus 4 gives us positive 2. That is correct. Which means that x is equal to 4 over 3 or negative 2. So this is where our derivative is equal to 0. Now at this point, we can do our line analysis on y prime. We'll do this by graphing negative 2 as well as 4 over 3. Let's look to the left of negative 2. How about negative 5? 3 times negative 5 minus 4 is negative. Negative 5 plus 2 is negative. Negative times a negative is a positive. So to the left of negative 2, y prime is positive. In between negative 2 and 4 over 3, let's try 0. 0 minus 4 is negative, 0 plus 2 is positive, and negative times a positive, that's negative. Let's look to the right of 4 over 3. How about 5? Positive, positive, so this is positive out here. Furthermore, we can conclude that y is increasing on the interval from negative infinity to negative 2 union 4 over 3 to infinity because y prime is positive in those areas. And y is decreasing on the interval from negative 2 to positive 4 over 3. And there's our analysis. I graphed this equation on wolframalpha.com and it looks like this. Now from negative infinity, x equals negative infinity, up until negative 2, y seems to be increasing because y prime is positive, the slope is positive. Then from negative 2 up until positive 4/3 right here, our function is decreasing, it's going down. And then from 4/3 up until x equals infinity, this thing has a positive slope all the way up. Let's look at one more. Y equals e to the x squared. Well, let's first take the derivative. So dy over dx, we have to use chain rule here. E to the stuff. The derivative of e to the stuff is e to the stuff times the derivative of the stuff, and the derivative of x squared is 2x. So our derivative, we can clean it up, is equal to 2x e to the x squared. Let's set this equal to 0. Now, e to the stuff is never going to equal 0. The only way to make e to the stuff equal 0 is you have to let the stuff approach negative infinity. But that makes no sense. We're never going to approach negative infinity here. So this component right here, e to the x squared, that's always going to be positive. However, we have 2x. 2x is equal to 0 when x is equal to 0. So the only time when our derivative, dy over dx, is equal to 0 is when x is equal to 0. It's at this point that we're going to do our line analysis. So here's the graph of y prime, and here's x equals 0. To the left of x equals 0, how about negative 1? 2 times negative 1 times e to the 1, that's negative. How about to the right of 0? Like positive 1. 2 times 1 times e to the 1, that's going to be positive. So for this particular function, y is increasing on the interval from 0 to infinity, not including 0 because the derivative is equal to 0 at x equals 0. And furthermore, y is decreasing on the interval from negative infinity to 0. And to get an idea of what this looks like, here it is. So from negative infinity up until 0, y is decreasing. And from 0 to infinity, y is increasing. And that is how you analyze increasing and decreasing functions.